The distance between two very long parallel wires is 0.18 meter. Currents of 8 ampere and 12 ampere are flowing in the same direction in the two wires respectively. Find a point on a perpendicular line joining the wires where the field intensity is 0. Let the field intensity be 0 at a distance x meter from the wire carrying 8 ampere current. Therefore, mu0 I1 upon 2 pi x is equal to mu0 I2 upon 2 pi into 0.18 minus x. Therefore, 8 upon x is equal to 12 upon 0.18 minus x. Therefore, 20x is equal to 1.44. Therefore, x is equal to 72 into 10 raised to minus 3 meter. Therefore, the intensity of the field will be 0 at a point 72 into 10 raised to minus 3 meter away from the wire carrying the 8 ampere current. A charge Q is uniformly spread over a disk of radius r made from a non-conducting material. This disk is now rotated about its geometrical axis with frequency f. Find the magnetic field generated at the center of the disk. The disk can be considered to be made up of a series of rings, each of an infinitesimal width, dr. One of such elemental ring of radius r. The charge per unit area of the disk is equal to Q upon pi r square. Therefore, the charge on the elemental ring under consideration is equal to Q upon pi r square into 2 pi r dr. Therefore, the current due to this ring when the disk is rotated is I is equal to Q upon pi r square into 2 pi r dr into F. The magnetic field at the center of the disk due to this current is equal to mu0 into I upon 2r. Therefore, dB is equal to mu0 into Q into 2 pi r dr into F upon pi r square into 2r. Therefore, B is equal to mu0 qf upon r square into integral 0 to r dr. Therefore, B is equal to mu0 qf upon r. Obtain the expression for the magnetic field at the midpoint on the axis of a solenoid with n turns per unit length of length L, radius A, and carrying a current I units. B is equal to mu0 Ni upon 2 into sine alpha 2 plus sine alpha 1. Cot alpha 1 is equal to 2a upon L Therefore, 1 plus cot square alpha 1 is equal to 1 plus 4a square upon L square. Therefore, cosec square alpha 1 is equal to L square plus 4a square upon L square. Therefore, sin alpha 1 is equal to L upon L square plus 4a square raised to half. Similarly, sin alpha 2 is equal to L upon L square plus 4a square raised to half. Using these values for sin alpha 2 and sin alpha 1 in the expression for B, we get B is equal to mu 0 ni upon 2 into 2L upon L square plus 4a square raised to half. Therefore, B is equal to mu 0 nil upon L square plus 4a square raised to half.